All right, so in this activity, it's asking us to make a spreadsheet. Again, it's given us the equation so we can actually create the table of values. So we're going to create a table of values of where y is equal to 3 to the x, and that's for x's from 1 to 7. So x is going to go 1, 2, 3, 4, 5, 6, 7, and my y values are going to go along with them. So I'm basically just using my x's as my exponent. 3 to the first power is 3. For the 2, 3 to the second power, 3 squared is 9. 3 to the third power is 27. 3 to the fourth power is 81. 3 to the fifth power is 243. 3 to the sixth power is 729. And finally, 3 to the seventh power is 2,187. And then step 2 tells us to go ahead and do the finite differences. It says analyze the data using the method of finite differences through at least the third set of differences and describe what you observe. Okay, so that means I'm going to do this first line. So I'm going to do 9 minus 3, and I'm going to get 6. And 27 minus 9 is 18. And 81 minus 27 gives me 54. 54. And 243 minus 81 gives me 162. Obviously, it's not linear, right? 162. 729 minus 243 gives me 486. Oops, 486. There we go. And 2,187 minus 729 is going to give me 1,458. 1,458. So now let's see if it's quadratic. Let's go ahead and do another subtraction. So 18 minus 6 is going to get us 12. 54 minus 18 is going to get us 36. 162 minus 54 is going to get us 108. 486 minus 162 is 324. 1,458 minus your 486 will get us 972. So it's not quadratic because we got to the second line of differences and it's not constant. So let's go ahead and do the third line of differences. So 36 minus 12 is 24. And 108 minus 36 is 72. Oops, keep pressing that button. And 324 minus 108. 324 minus 108 is 216. And 972 minus 324 is going to be 648. 648. Okay, so that's all it said we had to do was to the third set of differences. And we can see we don't end up with anything constant, but there's something else that I want to show you. And it's the fact that we will actually run out of the ability to do this any further. So let's say if I wanted to see if it was quartic to the fourth degree. So 72 minus 24, I'm looking at 48. And 216 minus 72 is 144. And 648 minus 216, I have 432. Well, I can still see that it's not quartic. Those don't match. Let's go down one more level and see if it's fifth degree. 144 minus 48 is 96. And 432 minus 144 is 288. 288. So you can see I was not able to go in, I can't go further than this because I have no other number to match it to see if it's constant. So the best I can say here is that I cannot find a polynomial of degree 5 or less that would be a good model for this data. I can't say what it is, except for the fact that they did give us the equation, so we know it's exponential. But the process that we just did does not tell us it's exponential. Okay, it's only because they gave us that in the beginning that we can look at that. If you remember way in the beginning of this lesson where we said that we can tell if we have n number of points, okay, in this case it would be 7 points, we could determine at n minus 1 if it was a degree less than n minus 1. Well, n minus 1 would be 6. So I could determine if it's less than a 6th degree or not. And sure enough, I was not able. I run out of things. That's the limitation. One of the limitations of this process is that I can only go as far as I can with the given number of points. The more points I have, the more levels I can go to and check for. But if I'm only given 7, the highest degree I can check for is 5.